day everyone, today I would like to talk about the derivative of a constant rule. It's a very simple rule, so here it is. If you have a function f of x, let me say c, then the derivative of that function is 0. Okay? I'll give you some couple example. F of x is equals to 19. Then the derivative of that f according to this rule is 0. Okay? It doesn't matter if you have a positive or negative number. Let me say negative 2.73. The derivative of that f is 0. Okay? Thank you for watching.
Hey guys, today we are going to solve constant times of function. So we have here is f of x is equal to 3x cubed plus 4x squared. So what are we going to do is we need to bring down the 3 and the 2 because the formula of this is n minus 1. So let's go. So first the step 1 here is to bring down the 3. So f of x is equal to 3 times 3x squared plus 4 times 2x. So the 3 became 2 because the formula for the exponent is n minus 1. So we minus the 1 into 3 in the 3, and it is 3 minus 1 is equal to 2. So here's our first step for taking the derivatives of this function. So the next step is solving it to get the answer. So f of x is equal to 3 times 3 is equal to 9. Then bring down the x squared. So 9x squared plus 4 times 2 is equal to 8. Then bring down the x. So we don't have the exponent here because 2 minus 1 is 1. So 8x, because we all know that 8x, the exponent of it is 1. So here's the answer, guys. 9x squared plus 8x. That's it.
Hi there, I'm here to show you how to compute derivatives using the product rule. The product rule is defined as the product of the first function and the derivatives of the second function plus derivative of the first function and the second function. So here's an example that I'm gonna show you. F of x equals 2x plus 3 quantity 3x squared. So we can see that there is a product in the equation. Now we're gonna apply the product rule. The first step is we take the first term and the derivative of the second term. Then plus the second term and the derivative of the first term. After that, now we're gonna solve them by multiplying and combining like terms. Now there's your answer. Using product rule requires you to use it to take the derivative of harder products of functions. So that's it.
Quotient 2. Our formula is k of x times g prime of x minus g of x times k prime of x over k of x squared. Our problem is f of x is equals to 2x minus 1 over 4x plus 3 is equals to 4x plus 3. The derivatives of g is equals to 2 minus 2x minus 1. The derivatives of k is equals to 4 over 4x plus 3 squared is equals to 8x plus 6 minus 8x minus 4 over 4x plus 3 squared is equals to negative 10 over 4x plus 3 squared.
Hello, so we're here to talk about a little lesson about implicit differentiation. So let's dive into it. So we have this example, 3xy plus 4y squared. So the first thing we will do is we will differentiate the first term to its second term. This will be your first term and this will be your second term. So first term, we have 3xy. So we'll differentiate 3x from y. 3x times y. So as you can see, this is product rule, which we learned earlier. So we'll have 3x times the derivative of y, which we don't know, so we'll write dy over dx plus y and the derivative of 3x, which is 3. So we'll have the answer 3x dy over dx plus 3y. So this will be the answer for your first term. And the next thing we will do is we will solve for the second term. So we have 4y squared. So we will write 4y squared. We'll differentiate 4 to y squared. As you can see, we have the chain rule, which we learned earlier. So we'll have 4 again, so we have the chain rule, so we'll write 4 times 2 times the derivative of y, which is dy over dx close parenthesis 8y dy over dx. So your answer for your second term will be 8y dy over dx. So the next thing we will do is we will combine the answer from first term and the second term. Combine. Let's say we have this 3x dy over dx plus 3y plus 8y dy over dx. So we have this function and we will combine it. So as you can see, 3y is irrelevant for the function, so we will move it outside the equals. So we'll have 3x dy over dx plus 8y dy over dx is equal to negative 3y. The next thing we will do is to factor 3x dy over dx plus 8y dy over dx. So we'll have dy over dx times 3x plus 8y is equal to negative 3y. So, to get the value of the dy over dx, we will divide both sides by 3x plus 8y. So, we will cancel this and we will have the answer dy over dx plus is equal to negative 3y over 3x plus 8y. So there you have it. This will be the simple function of implicit differentiation.
About a function and its four derivatives. In watching this, you have already tackled all about the other derivatives like constant rule, product rule, chain rule, quotient rule, constant times the function, sum and difference, like that. So, asking for four derivatives in a function, I'm going to give you an example. So watch this. Ta-da! This is the example. So you have this function over here. 4x cubed plus 4x squared plus 7x plus 2. So in this case, we're going to apply the constant times the function and the constant rule as well. So let's go. Y prime is equals to, let's see, 3 times 4. 3 times 4 x, where n minus 1 is given, plus 2 times 4 x, where 2 minus 1 is given, plus, okay, so let's see here, 7x. So when you have x here, x will disappear for this derivative. So we'll have here 7. And of course, this is a constant rule that will turn into 0. So let's see the answers here. 4 times 3 is equals to 12. X squared plus 8x plus 7. So that's the first derivative. The second derivative, y prime prime is equals to 2 times 12, 2 times 12 x 2 minus 1 here plus 8, so there, plus 8, because we're going to cancel x. We have this kind of derivative. So 12 times 2 is equals to 24 x plus 8. That's the second derivative. The third, prime 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 is equals to, of course we only have 24x plus 8, so the answer is just 24. So having the fourth derivative, y prime, so we'll have here 24 is equals to 0, inserting the constant rule. So there you have it. So another example for you. Here f of x is equals to 6x cubed plus 9x squared plus 4x plus 3. We'll find the first derivative. Y prime is equals to 6 times 3 is equals to 18. X squared plus 9 times 2 is equals to 18. Also x plus 4. Insert constant rule, so we'll have 0. Y prime prime is equals to 18 times 2 is equals to 36. X plus 18. And the third derivative is equals to 36. There. And the fourth one, of course, will be 0. So there you have it. 4 derivatives. A function and its 4 derivatives. Thank you.
Hello, so today, right now we will tackle about a real-life application of differentiation. So this is John. John believes that he has a 600 kilometer of land. He wants to build a shopping center in his land, and he wants to maximize his land. So let's assume that this is John's land. So this will be x and this will be y. So the perimeter of his land will be 2x plus 2y, because this will be another y and this will be another x. So and its area will be xy. So getting the function to solve its derivative, its differentiation. So we'll have perimeter is equal to 2x plus 2y is equal to 600. So he believed that he has 600 kilometer of land. So first thing we will do is we will put the 2x outside the equal. So we'll have 2y is equal to 600 minus 2x. So after that, to get the value of y, we will divide both sides by 2. So the answer for y will be y is equal to 300 minus x. So this y, we will substitute this value to the area xy. So Next thing we will do is we will substitute the area xy. So we have area is equal to xy. A is equal to x times 300 minus x, which is the value of y. So A is equal to 300x minus x squared. So right now you have the function 300x minus x squared. So the next thing we will do is we will differentiate it. So we'll get its derivative. So a prime is equal to 300x will be 300 minus x squared minus 2x. So to get the value, so this will be the derivative of the area. So to get the value of x, we will move 2x outside the equals. So it will be 2x is equal to 300. And to get the value of x, we will divide both sides by 2. So we'll have the answer x is equal to 150. So John wants to maximize his land. So to get the maximum capacity of his land, we will substitute the value of x into the function 300x minus x squared. So we have 300x minus x squared, and we'll substitute the value 150. So it will be 300 times 150 minus 150 squared. So the answer will be 22,000 kilometers of land. So this will be the maximum capacity of John's land, and that is a real life example of differentiation.
I got the magic in me. Every time I touch that track, it turns into gold.